Hello everyone, my name is Shivam Agrawal and today we are solving third question of today's Leetcode contest. Find longest special substring that occurs thrice. It's second. So today's contest's second question was its first part, which can be solved using brute force. Now we'll be seeing that question's optimization, which means this second question. So if you have not seen that video of first question or the brute force solution of this question, you can simply watch that and then come to this video after watching that. So what we have been given here is we have a simple string S and a string is called special if it is made up of only single character. Okay. For example, ABC is not special and triple D, double Z, FF, so DDD, ZZ, F are special strings. Okay. Now, return the length of longest special substring of S, which occurs at least thrice. So, a special string should occur at least thrice, three times in the string is. Um, we have to return the length of that longest special substring of S, okay, which occurs thrice, at least thrice. If it is not possible, mm, then we need to return -1. Which means no special substring occurs at least thrice. Fine. So substring is a contiguous non-empty sequence which we know beforehand. And now let's see all the um, first of all, let's see what are they trying to say as special substrings. Let's consider first example. Four times A is given to us and A, A. So this is one string. Now this is another string and this is another string, right? So in this way, we have three special substrings, right? In this way, we have three special substrings. So let's see all the special cases, right? These are some cases which we have to handle while solving this question. Previously, the brute force of this question was to store all the special substrings and then count and then find out the longest substring. But in that question, the constraints were very smaller, but here the constraints are 5 into 10 to the power 5, which are very large, and we cannot use the time complexity n square. So we need to optimize that approach. So we have to figure out some way to do so. So first of all, let's try to understand um, what a special string is. A special string is a consecutive um, characters, right? Like, right? Same consecutive characters. So if we take um, like if we have all the consecutive characters string, like here we have four times a and another four times a, so we have two 4a character strings, right? In this way, so we have two 4a character strings, um, and this will only account for providing me special substrings, longest substring. Using these, we can find it easily. So we do not need to find each and every special substring. We need to uh, take care of only longest substrings which are having consecutive same characters, right? For example, in this case, first talk about this case, which has 5 times A. So we have here 5 times A. So 5 times A, let's suppose. One substring will be this one, another one will be this one, and another one will be this one, right? So this one, and this is this one, this is this one. So it states that if I have a string of length, suppose 5, then I can make one, two, three substrings, which I need to make. Okay, I can find three substrings in this string S. This is my string S. I can find three substrings in this. So what we can observe here is this is the length of the string, substring, special substring, right? And we need only extra two characters to find to form three consecutive substrings, right? To form three consecutive substrings. So in this way, if we have a five length consecutive string, uh, which is this, if we have a five length consecutive string, then we can find out the length of longest special substring which can occur thrice in this string S can be found by using subtracting 2 from this length, right? Because we need only two extra characters, because this itself is a three length string. Okay, we need two more such three length strings. So if we have extra two characters, then we will take this a into account and leave this last a, then a second string is formed. And if another a is there, then we can take this a and leave this a as well, this a as well. If we leave this a and take this a, another new string is formed. So in total, three strings are formed in this way, right? In this way, three strings are formed. Fine. So three strings are formed. This is the case when we have only single substring having consecutive characters, right? Now, if we have two strings, like at this place, we have two strings. Um, we have two strings, four times A and four times A again. Let's suppose A, 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 A. When we have these two strings, when we have these two strings A, 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 then both are of same length, right? And both are of same length. But we know that using the length string of length 4, we can find two three length strings, right? Uh, in this way. First one is this one, and second one is this one. So a string of length 3 is find out from this 4 length string, and from this string also we can find a string of length 3, in this way, right? A string of length 3 is found from this, and 3 3. So we have three same strings, same special strings present in string S. And these are all my string S, right? This is the string S, this is the string S, this is the string S, this is the string S. Okay. Okay. So this is so in this way, what uh, formula we get is in case for case two, if size of first string and if size of first string and second string becomes equal, if uh, first dot size equal to second dot size, then what we need to do is then we need to update our result with max of res comma um, second dot size minus one, like this. Simply, yeah, we can put it here. Okay, this is the uh, observation for second case. And what was the observation in case one? In case one, it was length minus two. So in first, we had to do res is equal to max of res comma of first dot size minus two. Fine. So in this we were supposed to reduce the size. Here we reduce the size by 2 to find out the maximum length of a special substring, which can occur at least thrice. In this case, when first string is equal to second string, then we can do in this way. And when we have a string, um, when the size of both the strings are not same, first string is bigger and second string is smaller in this case. Like in the first string we have 336 characters, and in the second string we have 5 characters. So in this case, what we get is a 1, 2, 3, 4, 5, 6. Now second string has a 1, 2, 3, 4, 5, 5 characters, right? So, and suppose we have a string of length 5, which we have actually. So, we can simply find out two strings of length 5 in this string again, right now. So, we can simply return the length of the second string. We do not need to reduce the size in this case. We can return the length of second. Okay, we can return the length of the second string in this case. We do not need to reduce because first string is larger, and we can find any number find two strings in the first string which are lesser than uh, first string. So what we can do is we can simply control it, and just we need to do is this, and if first dot size is greater than, okay, now we have handled the question for three cases. Now the last case is when we have mm, three strings of size 1, right? When we have three strings of size 1, then it is the only possibility that we take all of them into the count, and when we have three strings of length 1, special strings of length 1, then we can simply return the uh, string length of third string, right? Because third one will be our smallest string, and first one will be the largest, then second, then third, right? So if in case we are reaching the third string, we can update the res by max of res comma third dot size, right? Fine, it is updated. Oh, okay. So now we have handled the question for all the four cases, and we need to only now we need to do store the length of all the consecutive strings of having consecutive same characters, mm, right? For all the characters. Suppose, suppose. Hmm, in this in the string in the strings 2 we have a, so we have for a we have a string of length 4 and 4, and for c we have a string of length 2 and 1, and we will be storing in them in such a way that they comes in decreasing order, like first one is the bigger one, and next one is the smaller one, right? And now b, for we have only one string of length 1, right? uh, how we can do achieve this thing, like um, at the top we should get the maximum length. This can be done achieved through using priority queue, right? So we'll be using priority queue for this question, for this thing. So now let's move towards coding part of this question. It's pretty solved till now. Now simple part is left only. So for storing all the lengths of the consecutive characters string, we'll be using character unordered map of character comma priority queue for storing the lengths of all the special strings, longest strings we can say, all the longest strings having consecutive same characters. And priority queue we are using instead of vector, because in priority queue all the lengths will get arranged in a descending order, and at the top we will be having the largest length. So in this way we do not need to sort the vector at the later point, and the time complexity of the question will be reduced, because priority queue takes log n time, and when we'll sort the vector, then it will take n log n time. So it is a better time complexity thing. So we are using priority queue for that thing. And so let's see the code. N is equal to s dot size. Character c is equal to s0. Okay. First character we have stored, and length is equal to 1. Right. I is equal to 1, and we are taking a loop from I is equal to 1 to I is equal to n minus 1, right? So if s is equal to c, then length, if the next character is similar to the previous character, then we are supposed to increment the length, because we need to update the longest string only. And if it is not so, then we can uh, push this characters, like push the length corresponding to this character into the map. Okay, so length is the map's name, and c is character, and we are pushing the length into the priority queue, right? So c is equal to si. Now we have updated a character with this new character, and length is initialized with 1 again. And this is similar to this for pushing the last string into the priority queue. Now we'll be simply iterating on this map, right? What we'll be doing is character and id dot first. Using the id dot first, we'll be uh, taking our character. Using id dot second, we'll be able to access the queue corresponding to that character. And as since we need to only find out the top three lengths corresponding to that character, we are taking a count three to popping out three lengths from the priority queue. And first, second, third, these are the, like, first is the largest string length, second is smaller than that, and third is smaller than that. Okay, if the CNT is equal to 3, it means we have the longest string here. So first is equal to q dot top. At the topmost position of q, we have the longest string. And as we had seen here, when we have longest string, only one string we have, then we can update our result by using first dot size minus 2. So here we are doing same thing, first dot size minus 2. We are updating our result. If first dot size is first size minus 2 is greater than 0. But if CNT equal to 0, it means this is the second largest string present corresponding to that character. So, and I'm talking about all special strings only, right? I'm not talking about any other kind of string. So first is greater than equal to second plus 1. If uh, anything we can say, if first is greater than second, or if first is greater than equal to second plus 1, all are same, right? So in this case what we have done is, we had updated res with second. So res is equal to mass of res dot second. But if in case first equal to second and first is greater than 1, then we need to update result with second minus 1. Right. Then we had seen this thing here. When first equal to second, then we had updated it with second minus 1. Now, else we are having the third greatest character, third greatest string. So we can update this with this thing, and reduce the count to simply come out of the loop after getting all three characters, or solving the question on all three characters, because I all three lengths we can say, uh, for each character we want only three largest strings. No other string is required, right? So in this way our result will be finally updated. Let's try it out here. Yeah, it's working. Let's try submitting it, and it's submit. Okay. So this question is done now, and let's talk about its time complexity. What is its time complexity? A simple for loop is used here. Okay. A simple iteration is done here. But wait a minute. We have used priority queue over here, right, to push it. And priority queue takes big O of log n time complexity 2 for each operation. So for n times we are pushing characters. So it will be big O of n into log n. So big O of n log n, time complexity for the first loop. Now we are iterating over the um, over the we are iterating over the map, and for this the time complexity is big O of n. For the time complex for this the time complexity is big O of n into, now for 3 times I am accessing the priority queue element, so it will be log n into 3 into log n. So again, it will be simply n log n, we can say, because 3 is a constant value. And finally, we can say it as big O of n into log n value. Right. Let's talk about its space complexity. Its space complexity, uh, we can say, it's a space complexity. We are iterating over the loop to find out all the different strings. If if each character of the string will be different, then we will having those many different strings. So the length of the map will become that length, that become equal to the length of the string. So space complexity, and this is possible in the worst case, right? So space complexity in worst case for this question is big O of n. That is the length of the string, where n is the length of the string. I'm considering n as the length of the string, right? So big O of n log n is the time complexity for the solution, and space complexity is big O of n. Okay, so this question is done here. So if you have any doubt in this question, you can comment below in the comment section and ask them. And till then, bye bye, goodbye, see you soon. Thank you for watching the video.